that hard and then nothing. Oh, there's that. Graphing hyperbolas. We're going to have four-step process to graph, but before we do, I want to show you what the equations look like. You need to get these in your notes. We had equations that we had for circles and ellipses yesterday. Today we got equations for hyperbolas. Okay, we got x squared over a squared minus y squared over b squared is equal to 1. If I'm in a hyperbola that's written in that form, I'm going to have x-intercepts at a0 and negative a0. That means my hyperbola will look something like that. A hyperbola is two curves. Okay? My other form is going to be with the y first. So y squared over b squared minus x squared over a squared is equal to 1. If this is the case, and our x's first, we're going to have y-intercepts at 0b and 0, negative b, which means our hyperbola will look, oh, that was bad.
Oh my goodness.
Worst looking curve I've ever seen. Will look something like that. Okay? So those are the two types of deals that we're going to be looking at. That equation, both of these, looks very similar to yesterday's ellipse. There's one major difference between this stuff and yesterday's ellipse. Anybody know what it is? Look at your ellipse equation from yesterday. See what's different.
The negative.
Very good, Chase. Ellipse had a plus in between them, and now we got a minus. Nice job, Mr. Rutledge. So that's important for us towards the end of today's lesson to remember that. Good job, Chase. All right. Got what we need here? Got your stuff written down?
Not yet.
This one is on the prowl. Hey, Joey, you all right? Hanging out in the fine thing?
It's a rock.
All right. Some graph paper going on here. We are going to graph x squared over 81 minus y squared over 64 is equal to 1. Okay? I told you there was a four-step process. So as we do this one over here on the left, I'm going to note those 4 steps for you, and we'll get those down in our notes. Step 1 is going to be our intercepts. Okay, my x is first, so that means I'm going to have x-intercepts, so I take the square root of 81. So my intercepts here are going to be at 9, 0 and negative 9, 0. So step 1 was our intercepts. Okay. Step 2. It's called the fundamental rectangle. I just say rectangle. To get the rectangle's got 4 corners. So I'm going to get my 4 corners by using the square roots here. So I'm going to have a corner of my rectangle at 9/8. I'm going to have a corner of my rectangle at 9, negative 8. See where I'm getting those from? Negative 9, 8. And negative 9, negative 8. So those 4 corners are going to be the corners of my rectangle. Now some people, when they graph a hyperbola, will actually draw that rectangle. I'm not going to draw it, but I do need those 4 points. So I'm going to put dots on all 4 of those points. So go ahead on your paper while I'm doing it on mine and get those 4 corners dotted. I got to count on every one to get 9s and 8s here. Alright, so step 1 was we found the intercepts. Step 2, let's choose a color more red. Step 2 was the rectangle, and I just put the vertices of that rectangle, the corners. Step 3 is going to be the asymptotes. I was smart to write that right through that line, wasn't it? I didn't do very good there. The asymptotes are the diagonals of your rectangle. So that's why I needed those points, so I would know where I'm drawing the diagonals. Now when you draw your diagonals, like you're drawing here and here, don't draw point to point. You need it to extend. So extend them through both of those on there. See, I'm going to go in segments, so I'm trying to keep them close. Turn green up there, don't turn green. Alright, so step 1 intercept, step 2 rectangle, step 3 asymptotes. Now the last thing, I haven't actually plotted these intercepts yet. I probably should have done that when I listed them earlier. So if I go over 9 and up 0, and over -9 and up 0, see I've got, let me make them blue so you can see them. See, I've got those 2 intercepts there. So my last step, 4-step process, step 4, is just to draw your graph. Now this is not going to be highly technical. My rules for drawing, remember, go back a page, this is going to look something like this. My rules for drawing that is this has to go through those intercept dots, and these curves have to, you get the door, these curves have to stay within those asymptotes. Okay? So we've got to go through these blue dots. We got to get close to my dotted asymptotes, but not touch it. Okay, so that's all I'm going to do here. It's going to come like here. I'm going to start curving that way. Start curving up there. You're not going to be able to see this one on right in red. Remember, an asymptote is what you're approaching but never touching. So that'd be it. My actual answer for this are these 2 curves. Okay, so when we see this on a test or an assignment sometime next week, they're probably not going to draw those asymptotes for you. When we're doing it on our own freehand, we have to draw those asymptotes because this, like I said, this was not very technical at all, but at least those asymptotes get us in the right ballpark. So we got a little bit of help on that. Okay, not very difficult. Ready to try another one? We'll do one where it's the y-intercept one, so we can cover all that. Very good? Y squared over 4 minus x squared over 25 is equal to 1. All right, step 1, intercepts. What are my intercepts here?
4 and 25.
Nope. 225. Sorry. You're on the right road, but just for the intercepts, not the corners, just the intercepts.
2, 0, negative 2.
Close.
Or 0, 2.
Very good. When our y's first, they're y-intercepts, so it's going to be 0, comma, whatever the square root of that is. So 0, 2, 0, negative 2. There's my intercepts. Now Rachel got us started on our rectangle already. Make sure though the x, even though it's written second in this equation, x still comes first when you graph, right? So it's going to be 5, 2. So you're going to use 1, 2, 3, 4, 5, 1, 2, 5, negative 2, negative 5, 1, 2, 3, 4, 5, 2, negative 5, negative 2. Okay, so this rectangle now, step 1 was intercept, step 2 was rectangle, step 3 the asymptotes. From this rectangle, your asymptotes are going to be the diagonals. Alright, so my last step, to draw my curve so that it goes through my intercepts and stays inside my asymptote. I almost hit that intercept, but that didn't count. It doesn't make the point bigger. There you go. Okay, everybody good? Those aren't all of the different, like I've got another, I could flip-flop these and have a different type of ellipse. I could flip-flop these and have a different type of hyperbola. I could even make this be x equals ay squared and have a different type of parabola. But those are the normal standard forms of all those different conics. I told you that yesterday. I never knew what conics meant until just a couple of years ago. Anytime you're graphing a parabola, a circle, an ellipse, and a hyperbola, that's considered conics. So I'm going to give us an equation, and we got to figure out without graphing it which of those it is, which type of conic it is that we're dealing with. The dilemma's, of course, going to be it's not going to look like any of them, and we'll have to do work to get it to one of these. Okay? Ready to, I mean, you should already have all this somewhere, right? So ready to look at it? I got 9x squared equals 108 plus 12y squared. All right, and the question says identify the type of graph. So is it a parabola, a circle, an ellipse, or a hyperbola? Okay, I would say my first elimination would be parabola because both of them are squared. Okay, so see what Rachel's talking about there? So I can mark parabola out because both of the variables are squared. That's always the one I'm going to check for first. Okay, so parabola's out. Now none of the rest of them, it doesn't look anything like them. Probably need to get the x's and the y's on the same side of the equal sign, don't I? Yeah. So I might can subtract that 12y squared. Yeah. Be alright? So it's going to get me 9x squared minus 12y squared is equal to 108. Pause. I'm now marking out ellipse. Why? Very good. We got a minus sign. The ellipse has a plus sign. So we've eliminated parabola and ellipse. We got a 50-50 shot now with a circle and a hyperbola. What did a hyperbola always equal?
1. So divide by 108.
Ellipse. Very good. So we could change this to a 1 if we divided everything by 108. I got so aggravated first period, somebody said subtract 108. 108 minus 108 is not 1, Buttercup. I mean, I didn't know what else to tell them on that. So it would be to divide by 108. So I'm going to divide everything by 108. That is 1. Okay, so now it should look something like what we've done today, right? Look like a hyperbola. That can go farther, can reduce farther if we needed to write it that way, because we know that 9 times 12 is 108. So this would be the same as x squared over 12 minus y squared over 9 is equal to 1. Looks just like the stuff that we did today. That would be a hyperbola. Shows I am. Okay, we'll do maybe one more of those, maybe 2, we'll see what we need. That one would not be fun to graph. This 12 is not a perfect square. So you'd be having to count decimals or radicals. Alright, let's look at this will be an easy schmeezy one. Is that a hyperbola, an ellipse, a circle, or a parabola? It should be that fast. No work, you got to do it all. Zane's right. Why do we know automatically, Zane, that this is a parabola?
The y isn't squared.
Only one of the variables is squared. This as it is with the x being squared, you have to move stuff over, but it would be a normal one like that. Whenever you run into the case where it's the y that's squared, that's where you get your sideways ones. Okay, very good. Are you all right on that? You can figure these things out. All right, last thing we got to look at is graphing of square roots. So we'll do one or two of those. Make a new page first. There we go. I think I went to a new page. I was pushing too many buttons. F of x equals the square root of. All right. Good news first off is you can graph that one in your calculator. What makes you able to graph this one in your calculator and not the hyperbolas, circles, or ellipses? Very good. It's solved for y. So when it says y equals, which is what f of x means, like Rachel said, when it says y equals, you just type that in your calculator and graph that. I know this is going to be a special looking kind of graph because when I'm dealing with a square root, I got to have what kind of numbers underneath the radical to stay real. No? Positive. Very good, Zane. If I got negatives underneath the square root, that turns it to an I, and we're not graphing imaginary, so it's got to be positive. I'm going to look at this real quick. Go ahead and be plugging that in your calculator, and we can compare stuff in a second. No, I can plug a 0 in. 0 squared is 0. 4 minus 0 is 4. Square root of 4 is 2. I can plug a 2 in. 4 minus 2 squared, 4 minus 4 is 0. I can also do a negative 2. Because negative 2 squared is 4, and 4 minus 4 is 0. Okay? So when I plot those there, and I'm going to count on every line because your calculator will count on every line. So maybe I can look similar to yours. How should I connect that? Is that going to be just a V-like thing there, or what's it going to look like, Chase?
Like a little short stubby U.
Kinda. Which, in relationship to what we've been doing,
Half circle.
would be either a half circle or a half ellipse. Very good. So when you got these square root functions, that's what you're going to be graphing. Now, is there anything in the table where you did this? Go look at your table. Are there any y values that are below 0? What does it say on the y's? What happens?
Error.
It just says error there. Good, Rachel and Caleb. Very good. Okay? And you can do those. Those aren't a big deal to do those in the calculator. Alright. Last thing I got for you is I'm going to give you x squared minus y squared equals 16. And I want you to tell me, is that the graph of a parabola, a circle, a hyperbola, or an ellipse? Okay, there'll be a spot for you to type that for me in your classroom. I got to push some buttons first. mine, you might have to refresh if you don't see it yet.
Okay.